Saxon Algebra 1, Lesson 56. We have two topics today. The first topic is sets. As you can see, sets are not difficult to understand. Sets are really just a matter of vocabulary, of giving you the words to talk about numbers in a way that will probably seem perfectly logical to you. So don't get too caught up in the weird words that we're going to use. We're just describing groups of numbers. It's not a big deal, all right? There really isn't any calculation to these. We're just discussing ideas. After we do that, we're going to get into some concrete graphing, all right? And we'll practice that a little bit more. So let's talk about sets. There are two basic kinds of sets. The first group are called finite sets, okay? When we describe sets, we usually use a letter. Say this is set A, and we say equals, and then we use a bracket to set it up. And we might say, this is a set of four numbers. Let's say 4, okay? I was making the 5 as I said it, and my brain spit it out, the wrong number, the wrong word. So this is a finite set. The set of A equals the numbers 1, 3, 5, and 7. At one point, that was the set describing the ages of my 4 daughters. There was a time when they were 1, 3, 5, and 7. It's a long time ago, but that was a time, right? So a set can be finite. Look, there's just 4 numbers in it. We can also have infinite sets. Whoops. And it's really easy to see the difference. I can use these very same members, but look. Do you see the 3 dots I put right there? That changes everything. That means keep the pattern going, right? So this set B, our infinite set, is the set of 1, 3, 5, 7, and so on. So it also includes 9, 11, 13, 15, blah, 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 right? So these 3 dots create an infinite set, and we look at the pattern and know that it continues. When we write out sets, there are a couple rules. We list each item in the set only once. Let's say that I had a pair of twins, and at one point my daughters were 7, 5, the twins were 3, and then the baby was 1. I would not have to write 3 twice. Okay, once 1 3 is good enough to represent all the 3s. So we list each member only once, or each item, and then the other one is a housekeeping detail. We don't have to list them in order. See how I write them in order? It would be important in this one because we're establishing a pattern, but here I could have written them in any order. I could have written 5, 1, 7, 3. But I much prefer to list them in order because when we're trying to study the sets and draw conclusions about the sets, it's much easier if everything's neat and tidy. And you'll see that in a minute when we do some of the problems with sets. Now, let's take a look at the kinds of problems that John's going to generate for us to study this topic. 56.1. John says, represent the following members as being of the set K. Okay, look, here he says, represent the following numbers as being members of set K. Okay, so what he's saying is there's a set, it's called K, and these numbers are in it. Now I'm going to copy those down onto my paper so you can see them. The numbers are... You copy them too. Those are commas in between them. Okay, there are 10 items in all. So make sure you get them all. Before we go on, I'll give you a second to finish copying. Okay, so we want to call this set K. So I make a nice big K. Typically, we use uppercase letters for the names of sets, but you don't have to get too crazy about it. We put the equal sign, we put the opening bracket. Now we have to list each item only once. We don't have to put them in order, but I'm going to. It's so much easier. So the smallest, the least number up here is 0. And I'm going to cross them out as I include them. 2 zeros, I only need to write it once. Next number is 1. There are 2 of those. Then we have a 2. There's no 3, so I'll skip up to the 4. Then we have a pair of 5s and a pair of 7s. Okay, so I've gotten every number included. There aren't 10 numbers here because I didn't repeat the ones that repeated. But there it is, lovely set K, and that is the right answer. John does not bother to put his in order, so you don't have to, but you want to make sure all those elements are there. Okay. I can squeeze, I always deliberate whether or not I can fit it in. Same thing going on here. Represent the following numbers as being members of set L. So I'll copy them down. Oh, this is 15, not 5. Sorry. There are only 9 members this time. Okay, so we'll do the same thing. We say, okay, this is set L. Open the bracket. Now let's just pretend I don't notice that minus 13 down there. That's fine. I'm going to start at the 0 as my least. Then I get a 1. And I look through and go, okay, it skips quite a few numbers here. The next one is 7. Then we have an 8. Then we have a pair of 15s. I'll write that once. Then we have a 42. And then I go, oh no, I missed the 13. So I can just add that at the end. That's fine. When I get everything in there that I believe should be there, I close the parentheses. All right? This is also a correct answer. Again, John does not bother to put them in order. I came close to putting them in order. I just tacked the minus 1 down at the end. There's no right or wrong answer to that. All right? Now, one other symbol I'm going to introduce in this next example. In this one, we're given 3 sets. There's set A. John gives us this in the problem. He says set A has those members. Set B has these numbers. And set C has those. Now we're supposed to answer these questions as true or false. And let's take a look at them. The first question, A, is that. What in the name of John Saxon did I just write? 5, this says, is an element of. Or, as I learned it in my math, is a, not an, is a member of. Okay, 5 is an element of A. So we look to set A and we say, okay, does that include 5? Yes, it does. So this is true. Not so hard, right? Okay, we're just decoding this. B. The next question is, 4 is an element of C, okay? This is kind of like a rounded E. It reminds me a little bit of the symbol for the euro, right? But the E helps me remember is an element of, but some students like is a member of, because that is a little more familiar word. Either way, 4 is an element of C. So we look at C, there's no 4 in there. So this one is false. And then the third one, 5. Now here's a new symbol. It's this, but it's got a slashy in it. And it says 5 is not an element of B. So we look at B, there's no 5 in there. So this is true. Yay, got all those right. Okay, that was 56.3. We have one more problem that works like this. See what I mean? There's no calculation in these. They're just kind of cute, easy little vocabulary problems. 56.4. Again, we have 3 sets. I'll copy them. You don't have to do that in your own homework. You can just look in the book. But it's hard for, if I put the book out here, it's really hard for you to see it. So I'm not going to rely on that. I'm going to copy them. M has the elements 5, 6, and 7. And N has the elements 0 and 1. Okay? So here are our questions. A, 6 is an element of L. I beg to differ. There is no 6 listed for set L. And B, 0 is an element of N. So we look to set N, we look for a 0. Yep. That's all there is to this, you guys. Which is something because we have to understand the notation, right? We have to understand what this means. We have to understand what that means. But not a real big deal. Okay, that is the end of our conversation about sets. Notice that we talked about infinite sets, but all of our examples were finite sets. No dot, dot, dots anywhere in place. Okay, let's return to our graphing fun that we've been talking about. So that's our next topic. We learned that when we graph, we like our equations to be in this order, and then we make a fun little table where we write the x's here and the y's here, and then we write this part of the equation in here so we can actually calculate them. X's, we get to choose whatever we want, and then we calculate the y's. All right, that's the part that blows everybody's minds in these is how do you know what to choose? Basically, you can choose whatever you think is going to be easy to calculate. Keep your numbers small, 0, 1, -1, +2, -2. Keep them close to the center, keep them small. If you have fractions, choose numbers that will allow you to cancel the denominators so that the fractions will go away. I don't want to say anything more about that just yet. In this problem, I'm going to leap right into it. And then from here, we generate pairs of points, right? And then we can graph those. We do at least 3, and they will make a line for us. Now, John has thrown us one, and we did this last time, right? I don't know which lesson it was, but we did this. Now, John's going to make it a titch harder for us. He asks us to graph this line. And the bells and whistles that I want to go off in your brain is that this isn't the right format. We need it to look like this. But look, our y is here and it's got a number in front of it, and our x is on the wrong side. It needs to be over there. So before we can build our table, we have to rearrange before graphing. And that is the motto of this lesson, rearrange before graphing. So all we have to do is some algebra to fix this. The first thing I would like to do is get this 3x over on the other side. Then we'll have 2y equals minus 3x. That's kind of unfortunate, but it's okay. Plus 4. And now we'll have to divide everything by 2 because we need this y to be by itself. That's what makes me decide to divide by 2. I need to cancel that. So we get y equals minus 3/2 x plus, this simplifies to just plain 2, right? So now it's in the proper format, and now we carry on with the problem just like we did before, all right? So this is what's new. It's called rearranging before graphing, all right? And you'll know that you're in trouble, like maybe you just don't even pay attention, when we want it in this form because we want to write this part here, minus 3/2 x plus 2. Up here, we don't have y equals, so we don't have the nice part that we want to write here, right? It has to be in this format so that you have the y by itself, and then the whole other chunk is what goes up in there, okay? Now we're ready to choose some nice values for y that will make for easy calculations. We've got a fraction here. So the first thing that comes to my mind is let's choose 0, because when we multiply this by 0, that fraction is gonna float off to heaven where it belongs. Minus 3/2 times 0 is 0. I draw a line through it. 0 plus 2 is 2. So our first point is 0, 2. Oh, I like that, right? Now, what we'd like to do is choose another number that will make this fraction go away. And what I immediately think of is, okay, the denominator's 2, so let's choose 2 for an x because then we can cancel. So we'll choose 2, so it's minus 3/2 times 2, and I can put it over 1 if that will help me with the multiplying. And then I'm going to give myself a little room here because look what happens. The 2's cancel. This becomes minus 3 over 1. I don't even have to write the over 1. I can just write minus 3 plus 2, which adds to minus 1. So my second pair of points is 2 minus 1. And then that 2 worked out so well, I'm going to use minus 2 this time. So it'll be minus 3 over 2 times minus 2 over 1. And then plus 2. I give myself room to write the product here. The 2's cancel. The 2 minus signs turn into a plus, so it's plus 3, right? These 2 cancel. There's the 3. There are the 2 minus signs that turn into a plus. So this is 5. And so my third pair of points, I'll write them down here, are minus 2, positive 5. Now I'm ready to graph. That problem got a little crowded, so I'll give myself plenty of room down here. And I'll just throw a few hashes on my Cartesian coordinate system. I'm not even going to bother putting them on the, well, I will. Makes it a little bit easier for you to see, I think. Okay, I just threw some on. I'm not going to number them. That's too messy. Let's start graphing them. 0, 2, there's the first point. 2, negative 1, there's the second point. And negative 2, I need one more. 1, 2, 3, 4, 5, all the way up to the top. Negative 2, 5. Oh, that looks pretty good, doesn't it? That looks like that's going to give me a nice straight line. I use one of my patented straight edges, right? Whatever you have handy that's straight, the edge of your book. That wasn't the most perfect diagram, but we can see with a clear ruler I could have done better. This piece of paper works really well for doing it too. Right here, I'm gonna make a big mess by drawing it again. Oh, that looks much better, doesn't it? Okay. The idea is we want to draw a straight enough line to ascertain that all 3 points really do lie on that line. The more handmade and wonky your graph is, the more likely you are to be off. But if you use graph paper, or at least work neatly, you should be pretty close. The name of this line is y equals minus 3/2 x plus 2. And every pair of points on this line will make that equation come true. That's kind of cool, isn't it? It goes infinitely up here and down here, but every single pair of points will make it come true. How fabulous. All right. This is called a line, but sometimes we call this a linear function. Don't let that word function scare you. A function is just a picture, a mapping of 2 points that correlate. Every x maps to a matching y, right? Every time I plug 0 into this beastly thing, I'm going to get 2. One day I'm not going to wake up, plug 0 in, and get a different number. It'll always be 2. There's a mapping, there's a partnership between the numbers we choose and the numbers we calculate. And we can draw a picture of the shape that they will take. That's what a linear function is. Yay. All right, do we have another one? We do, we have one more. So this time we'll practice everything we just learned and maybe go a little faster. The object is not to race, but on the other hand, you don't need to drag this out. 56.6. Ready? Graph. Y minus x equals 0. Ooh, that looks weird, doesn't it? All right, well, it doesn't look quite right because we know we want this. Y equals mx plus b. That's our goal. So we can see that the x is trespassing on the left side. We need to kick him over. So we'll add x to both sides. Y equals x. Okay, now that doesn't look, it looks closer, but it's not quite right. Here's what we can do if we really want to fill in all those blanks. Our m can be equal to 1, and our b can be equal to 0, right? M equals 1 times x plus 0 is the same as y equals x. So if you feel better filling those in, that will work. We can also use it just like that. All right? All right, we're ready to make our table. We will choose values that make it easy to calculate. No fractions this time. And what's really fun is, look, y equals x. Remember, this is what we write in the chart. It's just x. So what this means, problem that is so easy that you are actually hard, is that whatever we choose for x, y will be the same. That's all it is, right? So we can choose, let's choose minus 2. This middle column doesn't even make sense in this problem. Whoops, minus 2, I didn't need parentheses on that. And let's choose positive 1 would be 1. All right, well that's just ridiculously easy, isn't it? So let's graph. So here are our points. I didn't write the pairs down here, but we can easily find them. 0, 0, negative 2, negative 2. So let's see, I need to go negative 2, negative 2. There's a point. And then 1, 1. There's a point. And we can see, oh yeah, those are going to line up real good. bring my fancy straight edge in, draw my line, and there it is. There's our line. The 3 points line up nicely. Remember that if your 3 points do not line up nicely, that means you've probably made a mistake in your calculation over here. I mean, heaven help me if I made a mistake in this calculation. But you can see how, like in our last one where we were multiplying by -3/2 and we had fractions, it would be easy to make a little calculation error. So if your points don't fall into one single line, go back and look at your calculations and see if you made a mistake. You probably did. That's the most likely explanation. That's also why we choose 3 points here. It's because if we just chose 2, we wouldn't necessarily catch a mistake. But if we choose 3, we'll have pretty good insurance that we did it right if all 3 of them line up. You could choose 4 or 5, but we don't need to do extra work. This is fine. The name of this line is y equals x. And I really like to see my students label their lines. I want you to remind yourself that the name of this line is that equation. Every single pair of points on this line will make this equation come true. Holla, that's so cool. Also remember, I'm going to say it again, we can call this a line. We can also call it a linear function because there is a mapping between the values we choose for x and the y's that they will create. And they will always match in the same pairs, right? If we come back tomorrow and plug 0 into this equation, this line, we're going to get the very same point over here. It will never change. That's what makes it a function. It's a linear function because it makes a picture of a line. All right? Beautiful. Guess what? We're done. All right. If you are a local student, I will chat with you sometime in the next day or two. Good luck finishing up your homework. I'm thinking if there's anything else I can tell you. Remember to use your solutions manual as a tool. You may look at it, but do not copy from it, right? Look at it, figure out what you might be doing wrong in any particular problem. Check your answer. Do not copy it. If you did something wrong, study what John did, but then close your solutions manual and go back and do your writing without the solutions manual in front of your face. Okay, I'm done talking. Thank you. Goodbye.